Hello, civil engineers. Welcome back to the lecture. So once we have done with the footing bar bending schedule, the next is that we are supposed to take care of the column bar bending schedule, right? Now again, what you're supposed to do, whatever you have to create a new sheet, okay? Create a new sheet, something like this, and whatever you had written at the top, no, like this project, the serial number, everything you have to copy and say Control C and come to the next sheet, okay, and say Control V. Got it? So everything will get pasted, and similarly try to drag few of the things, okay, and here few things are not required, we'll delete all those things. For example, this column and this column, since we had used it for the BBS of the footing, that is not required. You select that two column and say hide, so it will get hide, it will get hided, okay, and then you can drag it in this way. Then again, after that, rest all things let it be there. In this again, we are supposed to delete one or two column which is not required. Rest all things look similar. Okay, you just drag it. It's good. Now here, type of the element will be column now. So you make the changes as, make it as column. Okay, good. Then lap length will be there, development length. This you can make 50 and this you can make 50. Okay, both will keep. And this is total steel quantity in column. Okay, these are the few changes which you are supposed to do now. Other than that, concrete cover, it will be 40 mm. For footing, it is 50. For column, it is 40 mm. Okay. Grade of concrete is same and rest all things are okay. Now, along with this, what changes you are supposed to do? We'll start that. Okay. Let me go back to the drawing. Number of bar, die of the bar, let the spacing, number of bar, yeah, let everything be there, not an issue. This spacing is not required for the column main bar, but for the stirrups we require, and for the lateral ties it is required. So let this be there. Okay, finish. So everything is correct. You just give a thick box, fine. That's it. Now, before we start with the column reinforcement, column BBS, we need to understand certain basics. And once we understand that, once we do it manually, then we'll go with the Excel sheet. Okay. Up to here, you correct and keep it. Now, first we'll go with the drawing. Okay. Now, see for the drawing, what you're supposed to do. This is a drawing by the name residential building BBS. This is what I've uploaded. You have to download the same drawing, and this drawing you're supposed to follow. The reason is that there are few changes what I've done. So that is why you have to follow this drawing. In the initial day, I mean, in the quantity estimation, I had given you one drawing. There also the schedule of column is there, but don't consider that drawing. This drawing you're supposed to consider. Okay, because the BBS is made according to this drawing. Later I'll take you that drawing and I'll explain you that also, because that is a bit complicated. So since we are learning it for the first time, I don't want you to get complicated. So that is why we'll go with this drawing. This is, I made certain changes in this, follow this. So the name of the drawing will be residential building BBS. Okay, this drawing only I've uploaded, you can download and use it, fine. Now here what has happened, all the columns they have given, right? What is the size of the column? 200 by 300, 200 by 300 is the size of the column. And in column usually we have two types of bar. Okay, one is called as longitudinal bar, that is this particular bar which will go straight in this way, okay, which will have a L shape. This is called as longitudinal bar, or we call it as a main reinforcement. And then we'll be providing the lateral ties. It is actually a lateral ties, few people call it as stirrup, which is not right. We call it as lateral ties in case of the column. Okay, this much is understood. If you're not clear here, I'll show you one or two images so that you understand. Yeah, for example, this is called as longitudinal rebar, the one which is going vertical. Okay, it's called as longitudinal or main reinforcement. And then the one which they have provided here, this one, okay, the ring, a kind of a ring, you can see this ring, this ring, this is called as lateral ties. This two we are supposed to find. Okay, so that is why whenever you look into the drawing, you get it something like this. The size of the column is done, it's written main reinforcement, that is the vertical bar. You're supposed to make use of 12 diameter bar. How many number? 6 number. To put it in a better way, like it is like this. So there will be 1, 2, 3, 4, 5, 6 longitudinal bar will be there. Okay, that is what you mean by that particular statement, this thing. Okay, and stirrup, this should be lateral ties. This people have written stirrup, it's okay. It's written you're supposed to make use of a 8 bar for making a lateral ties, and the spacing between them should be 200 center to center spacing. So that means, again, if I go back to the drawing, go back to this practical image. So this is your lateral ties. Okay, this is your lateral ties, this is lateral ties 1. Okay, in this way, this is your second lateral ties, and the spacing between this lateral ties, from this lateral tie to this, it has to be a 200 center to center spacing. This much is understood. 200, 200, 200, 200, 200, and this rebar is should be made use of this ring should be made from a 8 bar. Okay, this much is clear, no? Fine. That's it. Now they have given all these things like how that ring should be. You have two rings. One is called as master ring, which will be something like this. Okay. The same thing what we can see here. This is that master ring. Okay. This one, which has gone completely, no, this circular. I mean, this one rectangle. It is completely gone. No? That is master ring. Along with that, in few of the structural drawing based on the requirement, we have given one more link. This is called as a link. We have seen all these things. I hope you know what is this link and all, because it is taught in my basic drawing reading course and in my site engineer course and all. Okay, I think again there's no point in explaining that same thing. Okay, it is already explained. Okay, so because I don't have even image for that now. If you don't have much knowledge, you just message me, I'll explain you that. But again, I'm thinking that since it's an advanced course, I'm thinking that you know all these things. Again, I'll not go and show you each and everything. Okay, done. Fine. If you still have doubts, you can get back to me. Okay, not a problem. Okay, this much is understood. Chalo. Fine. Then again, now one thing we need to understand, whatever they have shown, no, it is from footing to the ground level. That means your column, for example. Okay, so how do I explain this? Yeah, we'll see. Now, few your time will go here just to understand few things, and once we understand, we'll go with the BBS. Okay, so directly I cannot take you to the BBS part since we need to understand few things from the drawing, and column BBS will take little time to understand and also to do it. Yeah. So this is a column reinforcement. Okay. So this is a column reinforcement. Your reinforcement will start like this. It will be over the footing like wait. It will start like this. Okay. Your bar will go and your bar will go straight in this way. Okay. Up to the whatever floor. If you have 5 floor, it will go up to the 5 floor. But not one single bar will go 5 floor. For that, you have to do lapping and you have to cut the bar and all. Okay. Getting my point? And here that is why these people have written like, see, this is up to the plinth level. This is to the top of the plinth beam. And from the plinth beam to this is your first floor. From first floor, this is your terrace. And from terrace, it is above the terrace. So let us say I'll remove all these things. Okay. This is not required. I'll do it in this way. Okay. So let us say this is my first floor. I'll write this as first floor. This is my first floor. This is my second floor. And this is my third floor. Okay. You're getting my point? So your bar will start from here. It will go. This is the top of your plinth beam. Okay. From there to here, this is your first floor. This much part is your second floor. This is your third floor. Got it? So how that bar has to go, that is mentioned here. Where it has been mentioned, it's written in this way. See? From the footing to the ground level, this is the reinforcement you're supposed to use. Okay. And from ground floor to the first floor, again, you're supposed to use of 12 diameter 6 bar. Okay. And then your lateral ties will be so and so, and in that way. Then again, from first floor to the roof level, you have to follow this particular drawing. Okay. And then roof level to the top of the roof level, it has to be followed in this way. You're getting my point? Okay. Now, why these things has to be given? Because if you're constructing a G+3, G+4 building, it's not that only one bar, whatever you take from the foundation, it will go to the top. That usually that, I mean, if it is a G+3 building, usually that happens. But when you're going for a very high rise building like a G+5, G+6, in that case that is not the thing. There what we try to do, we'll take a ground floor beam, for example. We'll take a bar from here. Let us consider it's a very high rise building. Okay. So from here, we'll take a, let us say, a 12 diameter bar. So this 12 diameter bar will go up to first floor. Let us consider. Fine. After that, from first floor to the, let us say, up to fifth floor, 12 diameter bar won't go. Let us say it will be a 16 diameter bar. Or let me put it in other way. Let us say from here, a 20 diameter bar is going up to the, let us say, first floor. Okay. And from first floor onwards up to the fifth floor, 16 diameter bar will go, because there the requirement will be less. So in that case, what we do, I'll go with the 16 diameter bar. So this is my 16 diameter. I'll give a lap here. Okay. And my bar will be, I'll take it in this way. Got it? So that is why when you write, that is why in the drawing it will be mentioned. This 20 diameter bar will be only up to the ground, up to the first floor. From the first floor to the fifth floor, it will be a 16 diameter bar. Okay. So that is why in the drawing it will be mentioned like ground floor to first floor, what you have to follow. Okay, from footing to ground level, 20 diameter 6 bar. Okay, then again ground level to first level, again it is a 12 diameter 6 bar. Okay, then again from first floor to roof level it is a 12 diameter 6 bar. Again roof level to top of the roof it is 12 diameter 6 bar. That means right from foundation up to the top of the roof, everywhere you are supposed to make use of a 12 diameter, which is 6 in number. So that is why this drawing I modified, because if you had taken my original drawing, there is a variation. So that variation I'll take it later, not now. Now we'll assume that whatever reinforcement we are getting in all the column from C1, C2, C3, diameter may be different, but the number of bar will be from the foundation to the top up to the G plus 2 building, everything it is same. This much is clear. This you have to fix in your mind and refer this particular drawing. This much is understood. Fine. So next we'll start with the BBS of my footing. Okay, so we'll start with the bar bending schedule of the footing. So how do you identify, how do you do the BBS? So for that, if you remember in my quantity estimation course, we had done this bifurcation, we had done this this thing, what is that, classification. That means we had separated the column based on the footing. Like my C1 column is coming on F1 footing, you remember, right? My C8, C12, C25 column is coming on F2 footing. My C9, 10, 11 and 20 column is coming on F3 footing. Now again I don't explain this because you know C15, 21, 22 is coming on F5 footing. C27, C17, C23, F is coming on F7 footing. Got it, no? How did we classify it? We took the footing, and on F1 footing, how many columns are coming? We have classified that. Then we took F2 footing. On F2 footing, whatever columns are coming, we have classified. How did we do that? Very simple. If I go back to that, this was the footing what we had, isn't it? This was the footing we had. We search for F1 footing. So where is my F1 footing? So my F1 footing is somewhere here. Yeah, F1 footing. So on this F1 footing, which column is coming? C1 column is coming. 1. Is there any other F1 footing now? So there is no other F1 footing, right? I think there is no other F1 footing. Finish. That's what we wrote, like this column, that is C1 column on F1 footing. The same thing you can see here. C1 column on F1 footing. Got it? Next, I'll go with the second one. Okay, I'll take one more just to clear out doubt. Now look for F2 footing. So where is my F2 footing? So there is one F2 footing here. Fine. On this F2 footing, which column is coming? C8 column is coming. Good. Is there any other F2 footing? Yeah, I have another F2 footing here. But which column is coming? C12. That means on F2 footing, I have a C8 column also. On F2 footing, I have C12 column also. And then again, where is my F2 footing? Another F2 footing is here, right? F2 footing, which column? 25. That means C25. Remember the column name. C25, C12 and C8 columns are coming on F2 footing. That is why I wrote here C8, C12, C25 column on F2 footing. The same thing, whatever we wrote there, based on that only we'll do the bar bending schedule. Now you'll ask me one question. So why it has to be done in this way? Because the height of your column reinforcement, whatever you're putting, it depends on the footing which it is coming. That is why this becomes very important for us. Otherwise, if you don't want to follow this, you can come and do individually. You can take one, you can take each one of this. You write first C27 column F7 footing. You do a BBS for this. No problem. You take C28 column on F8 footing. You do the BBS for this. You take C25 column on F2 footing. You do a BBS. You will get the right answer. But what will happen? The calculation will be very lengthy. So instead of that, once we group, it will be easy for us. Why? Because the moment you group and you go to the Excel, you prepare this Excel sheets, you just have to input here like we have done here. Okay. Like see, C8, C12, C25. 3 columns on F2 footing I told. So that is why I written number of member is 3. Then directly I'll get the answer. Otherwise, what you should have done, C8 column on F2 footing. You do this calculation. Then again you go for which one? C12 column on F2 footing. Again you do another calculation. Then again you go for C25 on F2 footing. Again you do the calculation. So 3 times it will be lengthy calculation. Instead of that, we have grouped that and 1, 2, 3 columns. So directly I've written 3. My answer has changed. Suppose there were 4 columns. If the moment I do 4 here, your answer will change. Getting? So that is why this classification has to be done. Clear? 2 things we have cleared now. No more doubts left. Now we'll start with to find the cutting length of the bar. Okay, fine. So find the cutting length of the bar. First, the main reinforcement I'll teach you how it has to be done. So before that, you should understand how the bars are practically placed. Okay, so you know that, but still I'll quickly give you an idea regarding that, how the bars are practically placed. Okay, So just that L shape I need to identify, and then we'll start with that. Yeah. So whenever you place the reinforcement, this is column reinforcement. So your column rebar will come from the top and it will be given a L shape here. This is the L shape. So whenever I find a cutting length, I want to find this length plus I want to find the height of that. If I add both, I'll get the total cutting length of the bar. If I find one cutting length of one bar, and if I multiply this by number of bar, like this is 119. So if I multiply like one, we have 2, 3, 4, 5, and let us say 5 on the other side. If I multiply this by 10, if I get 10 bar, so 10 into cutting length of one bar will give me the cutting length of all of my bar. Very simple. Chalo. Good. So this much is understood. Now we'll start with the real calculation of this. Okay. Yeah. So first what we'll do, go back to this Excel sheet. What I've written, C1 column on F1 footing. So in my BBS also I've written the same thing. Okay. First what I'll do, no, I'll directly teach you here. Then I'll teach you how to prepare the Excel sheet. First you understand the concept. Okay. Now here in this particular video, I'll teach you how to calculate the cutting length. And in next video, I'll teach you from the scratch how to prepare the Excel sheet, something like this. Okay, fine. So I've written here C1 column on F1 footing. And what is the size of my column? It is 200 by 350, which is given in the drawing. C1 column, they have given the dimension here. You have to pick from here. Okay. So my C1 column, where it is C1 column. So yeah, C1 column is here. See, C1 column is here. And for the C1 column, what is the size? It is 200 by 350. Same thing, I've written it here. Okay. I've written here 200 by 350. Now it is resting on which footing? F1 footing. So what I did, I wrote F1 footing. I wrote the size of F1 footing also. That is 1200 by 1200 by 400 mm is the depth of my footing. So in that what I've done, this 400 I've written, it's the depth of the footing because this depth itself is required for us to find the height of the bar. Okay, you write 400. Why did I write 400? Because my F1 footing depth is 400 that we got from the drawing. Now we need one more thing. In the F1 footing, what is the diameter of the bar? See, column we are finding, but we want the reference of footing also. So that is why I come to F1 footing. The depth was 400. It was 1200 by 1200. This reinforcement I require, that is L1 and B1. That is diameter along the shorter span and diameter along the longer span. So I'm using a 10 diameter bar in the bottom and also along the shorter and 10 diameter along the longer. So 10 and 10, no? So that is why what I've done, I've given an input here of saying that this is 10 diameter. Anything is okay. You take this as shorter, you take this as longer. Doesn't matter because we want this diameter. Got it? Fine. So now what we'll do, we'll start with this. Yeah. Yeah. So first we'll start with this. So first what you're supposed to find, this particular thing, this L shape I want to find. Okay. I'll go with this only. Yeah. First, see, I'll tell you what has to be done. So this is my footing. Okay. This is my footing. First, I just want to find, this is my footing. Okay. Your bar will come like this. Your bar will start from here. Your footing bar will, your column bar will start like this, and it will go on like this. Okay. We are not concerned with that. Right now, I'm concerned with only this particular length. Which is that length? This particular length I require. That is from the top of this column, top of the footing. This is your top of the footing. From this here to this length I require. Getting my point? This much length I require. Okay. If you want, I'll show it in this way. This particular length only I require up to here. Up to here, this length I require. How do I find that? So this length is nothing but it is actually a development length. If you remember, this length is nothing but it's actually a development length. Okay. So usually if you see the drawing and all, they mention like this is LD. Okay. From here to here, it is a development length. That is what they mention. And usually they mention that it has to be 50 times the diameter of the bar. What they mention? 50 times the diameter of the bar. Usually, most of the cases, they mention it in this way and write 50 into D. It's a development length. Okay. Here they haven't done, but most of the drawing they do. Suppose if I take you a few drawing, if I go back to this drawing, let me see. Yeah. See, exactly. This is what I wanted. See, from here, this is your footing. Okay. From the top, I'm just finding this length. Don't observe anywhere. Whatever I teach you, listen that. This length I want to find now. Where from here to here, this length I want to find. This length I want to find. Okay, great. So how do you find this length? This length they mention. See, LDT, this is development length in tension. Okay, but usually this entire thing is the development length, and they mention that it will be 50 times the diameter of the web, 50 into d. Okay, this much we got. This is entirely 50 into d. But when I do the calculation, I'll find it separately. This entire thing is 50 into d. Okay, but I want to find this height. How do I find this height? It's very simple. I want only this height. Okay, this entire thing is 50 into d. I'll do it. Let us consider I have a 12 diameter bar. Tell me what will be 50 into d? 50 into 12. It will be 600 mm, right? Simple. If I'm considering a 12 diameter bar here, what is the development length? It will be 50 into d. So 50 into 12 will be 600 mm. 600 mm? Yeah. 12 5 is 60. Yeah, 600 mm. Okay. So this is overall is 600. But now I want to say only from this vertical height how much it is, that I don't know. How do you find that? It's very simple. You know the depth of the footing. You know this depth. From here to here, you know the depth. From this depth, you know this overall depth. Okay. From this depth, if I remove the bottom cover, footing cover, if I remove, that will be 50 mm. And if I deduct this rebar and this distribution rebar, will I not get this particular height? I'll do it in this way. Okay. See, I want to find this height now. This height from where? From here to here. This height I require. How do I find this height? Very simple. Whatever is the depth of the footing, whatever is the depth of the footing, from there, if I deduct this, okay, I'll do it in this way. From whatever is the depth of the footing. From there, if I remove this cover, this will be cover, which is 50 mm. And in that cover, again, if I deduct this red color rebar, bottom rebar, and if I deduct this distribution steel, will I not get the height of this rebar? From here to here, obviously I'll get, because why I'm deducting this top distribution also? The reason is this L shape, this L bar is sitting on this bar. So if you're not able to understand this thing, I'll quickly show here. See here. This L, where it is sitting? This bar which is coming, no? It is sitting on which bar? It is sitting on 2 bar. That is, see, horizontally there is 1 bar passing and vertically there is 1 bar passing. Over that, this L is sitting. That is why overall depth minus bottom cover. This is cover, okay? 50 mm cover minus this horizontal bar and minus this, this shorter span bar and longer span bar. If I deduct, I'll get the straight length of my bar. Pretty simple. Same thing, I have done it in the Excel sheet now. Okay. So what I did, first I'll tell you how it has to be done. So how did I get, yeah. Yeah. Okay. So first I'll find this particular height. Just now, whatever I calculate, that I'll find. Okay. So what I did, I'll do it here again. 330 I'll bring. Plus bracket open. What is the depth of your footing? That is why I written depth here, 400. Now we're getting the importance. That is why I wrote F1 footing depth here, 400. Minus, exactly, 50 mm is your footing cover. Minus, I want the shorter span diameter. I want the longer span diameter. That is why I written 10 and 10. So minus this one and minus this one and close the bracket. Enter. How much I got? 330. So 330 is my vertical distance. Okay. Now, if I get the vertical distance 300, and I know that from here to here, from here to here, it is development length, which is 50 times the diameter of the bar. Okay. So out of this 50 times diameter of the bar, already my 330 length is calculated. If I, from 50 times the diameter of the bar, if I deduct this 330, will I not get this particular length? Obviously, I'm going to get. So next what I'll do, I'll calculate that. So that means, I'll do it here. Okay. Yeah. So plus open bracket, development length is 50 times the diameter of the bar. So 50 is already written here, 50. I'll multiply this by diameter. Diameter of which one? 50 into diameter of the bar. Okay. Yeah. Yeah. Okay. Plus 50 is here development length, multiply by column I'm doing. So column diameter I have to take 12. Okay. Getting my point, no? So fine. 15 to diameter of the bar minus this length, straight length, and close the bracket. Enter. How much I got? 270. Finish. Pretty simple. So this is 270 and this is 330. And if I add 330 plus 270, that will be equal to the development length. If you want, I'll verify that also. What is your development length? 50 into this one, no? 12 diameter. It has to be 600. 600. Okay, see, you may find it a bit confusing initially, but it's very simple. Yeah, it's very simple. 600. And if I add 270 plus 330, it has to be 600. So that also I'll do here. Plus 330 plus 270. Sorry. Plus 2. Okay, finish. It has to be 6. Matching, no? Finish. Very simple. That's it. You understood this concept? I'll quickly repeat it. I know the development length. This is LDC. Okay, I'll quickly draw it here. Okay, for someone who has not understood, I'll repeat it. For someone who has understood, you can skip this part. Okay, we know that this is the development length, what is given. It is usually 50 times the diameter of the bar. 50, usually. Sometimes, if it is not 50, sometimes they may say it is 60. In that case, you can write 60. Okay, 50 into diameter of the bar. This is my overall development length. But I want to find only this particular height. If I want to find this particular height, whatever is the depth of my footing, from there, if I deduct the bottom cover, which is 50 mm, minus if I do the shorter span diameter and longer span diameter, I'll get this height. So that is how I got 330. What I did, overall depth minus 50 mm cover minus shorter span diameter minus longer span diameter. I got this height. Finish. The moment I get this height, finding this L, finding this is very simple. How? Why? Because overall development length is 50 into D. In that, if I minus this 330, I'll get this horizontal. That is what I did here. So what I did, this development length, that is 50 into D. And when you take diameter, you should take the diameter of the column, not the rebar diameter. It's the diameter of the column, 50 into D. Okay. Minus this height, if I do, I'll get this horizontal length. So that's how I got. Pretty simple. After this, your calculation is very simple. So I found this vertical length. I found this horizontal length. Next, what I want to find? Next, I want to find the total height. That means, what do I mean by total height? That means right now, yeah. So right now, whatever calculation I have done, that is only up to here. Where from where this length I got, this length I found, and I found this length. That is only up to here I have found. But now again, I want to find from the top of the footing, from the footing, top of the footing up to the top. Wait, let me do that. Okay, this you can imagine, no? This is different. Yeah. So far I found this length I found, and I found up to here. Okay. Now my calculation is to be from this top of the footing to this complete height I'm supposed to find. This height I'm supposed to find. How I will do that, I'll teach you now how it has to be done. Okay. Yeah. So for that, few things I'll explain you anyhow. We'll start with this only. Yeah. Yeah. One thing I'll teach you here only. First time I'm teaching you here. I mean, first time you people are listening to me. So small confusion, those things will happen, but it's very simple. Okay. Fine. Next, what I'll do. Next, what I'll do. I want to find this height now. Next, I'll break it down. Now, this is a plinth beam top. Next, what I'll do, and this is plinth beam bottom. From the plinth beam bottom, that means plinth beam bottom is, this is your ground level. Okay. This is my GL level, ground level, from where you started the excavation. This is my ground level. Now, what I'll do, I'll start to find this particular height. If I get this height, rest my calculation is very simple. I want to find this particular height now. Okay. How do I find this particular height? It's very simple. It's very simple. Initially, if you look into the drawing, this height was actually given for us. From the ground level to the top of the PCC or bottom of the PCC, they are told that you have to do some 2 meter of excavation. 2 meter of excavation. Okay. So this 2 meter is given to us. That means this height is given to us. From this height, if I deduct this footing depth from the overall depth of the excavation, if I deduct the footing depth, what is left out? Will I not get this particular height? I'll repeat it once again. See, this is my depth of the footing. Okay, from the ground level I'm standing. From there, it was mentioned that you have to do the excavation till the bottom of the PCC, or let us say top of the PCC. It was 2 meter. It was 2 meter excavation. But I want to find only this height. From that excavation depth, if I deduct the depth of the footing, if I deduct the depth of the footing, will I not get this particular distance? Obviously, I'm going to get this particular distance. Will I not get? Obviously, I'll get. That is what I'm looking for. Now I'll go back to the drawing. We'll do the same calculation. Okay. Okay. So in the Excel sheet also, we have done the same thing, but I'll teach you here how it has to be done. So I'll go back to the drawing. Yeah. So now what my concern is to find this length. Okay. My concern is to find this length. For the same drawing I'm teaching you, I want to find this height from this to this. Okay. I want to find this height now. How will I find? Very simple. It's very simple. How do I find? Already see from this level, natural ground level to the top of the PCC. It is given you have to do a 2500 mm excavation. From this, if I deduct the thickness of my footing, if I deduct this particular thickness, will I not get this particular height? Obviously, I'll get simple calculation. So we know what is the depth of the footing, where it is mentioned. We are taking F1 footing. This is F1 footing, and the depth was 400 mm. Now just apply the calculation here. 2400 minus 400. If I do, it will be 2100. So this is 2100. Simple. The same thing has been done in the Excel sheet also. Okay. So what I have written here, see, 2500 minus D12. D12 means I've taken this one. This is D12. Got it? You're getting my point? Forget about other things. Forget about other things. Leave. And yeah, I'll do a separate thing for you. Okay. So plus, open the bracket. What I'll do now, I'll say depth of excavation is 2.5 or 2500. I'll write 2500 minus how much? Depth of footing is how much? 400. Finish. It is 2100. So this particular height is 2100. Now where did we reach? That is important. By doing this calculation, where did we reach? We reached till the bottom of the plinth beam. We reach up to the bottom of the plinth beam or natural ground level. Now from here onwards, our calculation is very simple. I'll take you to this drawing. Right now, where did we reach? We reached to this particular point. Okay. See, it's very simple. If you're getting confused, just wait for 1 or 2 lecture. After that, you will master this. Okay. It's very simple. Now, we did everything. Okay. We found this horizontal length, right? Agree with me? And we found this vertical length up to here, up to the bottom of the plinth beam. Now, after this, what we are supposed to do? After this, I want to find this particular height from here, from the bottom of the plinth beam to the top of this, I want to find. It's very simple now. What all things you can observe? We were here. If I add the depth of the plinth beam, and if I take all the floor, this is the ground floor, this is first floor, and this is my second floor. Okay, this is my first floor, this is my second floor, and this is my roof. And if I write the floor to floor height is 3 meter, floor to floor height is 3 meter, floor to floor height is 3 meter, and this plinth beam depth is 450 mm. 450, I'll write it as 0.45 meter. If I add all these things, will I not get the complete height of this bar? Very simple. We reached up to here. I'll add 0.45 to that. So I'll reach to the top of the plinth beam. And now from the top of the plinth beam, that means you're actually in the ground level. From ground level to the first floor top, your height is 3 meter. From first floor to the second floor, your height is 3 meter. From second floor to the terrace, your height is 3 meter. If I add 3 meter, 3 meter, 3 meter, plus if I add 0.45, and if I add all these things with the previous answer, will I not get the complete height of my bar? Obviously, I'll get same thing I'm supposed to do now, right? I'll do the same thing in the Excel sheet. So what I did now, up to here I reach. So now, yeah, up to here I reach. Up to this point, I'll put a bracket here. Okay, close the bracket. I mean, open the bracket, close the bracket. Okay, plus what is the depth of your plinth beam? For that, what you have to do, you have to go back to the drawing. See, few things you have to go back to the drawing. And in this drawing, our plinth beam was actually 350 mm, if I'm not wrong. In the quantity estimation, you have seen that. Okay, for that, I'll come here. This is my plinth beam. And if you see plinth beam, depth of the plinth beam was 350 everywhere. So I'll take 350. Okay, how did I get 350? All these things will be given in the drawing. If you had followed my quantity estimation, there we had taken the depth as 350. So what I'll do, I'll take 350. I'll go back here. Okay, so I'll write 350 mm. Finish. Now where did we reach? Tell me, where did we reach? We reached till the top of the plinth beam. So top of the plinth beam is ground level. From ground level to the first floor, what is the floor to floor height? Where it is written? Again, you have to go back to the drawing, come to the drawing. So if you take this section, this is my section what I had, isn't it? So if you remember, this was the drawing what we had. And what was mentioned here? This is your ground level. You can see from the ground level to the first floor. What is the height given? 3.3 meter. From first floor to the roof floor, what is the height given? 3.3 meter. From the roof to the top of the roof, what is the height given? 3.3. That means my floor to floor height is 3.3. How many floor is there? We are looking into a G plus 2 building. ground floor, first floor, second floor. That means it's a G plus 2, no? From ground floor to one floor is 1, from first floor to second floor is 2, and from second floor to the roof it is 3. That means 3 times I need to add 3.3, 3.3, 3.3. Only then I'll reach to the top of this. Okay, getting my point? If it is G plus 2, that means 3 floors will come. G plus 1, 1 floor, plus 1 to plus 2 another, then another roof will come. Okay, fine. So that is why what I'll do, plus 3300 one time. This from here I'll reach to the first floor. From first floor to second floor I'll reach 3300, and from there a roof will be there. Okay, 3300. Finish. Everything is done. Hit the enter button. How much I got? 12 12350 I got, right? But here I got 14110. What is the reason? The reason is that two things we didn't add. The bar which will go to the top, this bar, where is that? This bar, the bar which will go to the top. From here you started your bar, no? It will go to the top, but it won't go to the complete height. I mean, it won't touch here. We'll leave a gap of, you will give a gap of 40 mm. That is called as column cover. So it won't go completely here. You'll leave 40 mm and you will stop the bar here, right? In the footing, what we were doing, 50 mm cover we were leaving on the sides and even on all the four sides and even the bottom and the top. Same thing in the column also. We are supposed to do that. Okay. Same thing in the column also. We are supposed to leave a gap of 40. Gap means a cover of 40 mm. Okay, so that is why what we'll do, we'll come back to the Excel sheet and we'll write minus 40 now, minus 40, and I'll hit the enter button. Is it the answer matching here? No, still the answer is not matching. Why? Because for a very same reason, what is the total height we are getting? 12,12310. That means 12.31 12.310 meter. We already written the height of one bar, the height of rebar length, what we have written, 12 meter. Okay, after 12 meter, you have to join one more rebar. So that means there's something called as lap. You have to add the lap length also. You have to add the, I mean, you have to deduct the, yeah, you have to deduct, you have to add the lap length also. Okay, you're supposed to add the lap length. So again, I'll go back to the drawing. See here. So what will happen, this lap length, I'll teach you. So you'll start your bar from here. Okay, you'll start your bar from here. It's a 12-meter bar which you're going to start, and it will go up to here. Okay, it will go up to here. Finish. After that, you will add one more bar. This is your next bar. What you'll do in the next bar, you'll do the lapping. Lapping means you will bend the bar here. It will lap here. It will go to the next floor. Finish. This bar will stop here. Then you'll bring one more bar. Okay. Again, this bar will come from here. You'll give a small crank and it will take into the top. Okay, finish. You're getting my point. Then again, it will, another bar you're going to bring. You'll bring another bar. Okay, bring another bar. You give a crank. Okay, like this, and you'll take it to the top. So this is called a slapping. So whatever this lap length is happening, no, that will be mentioned in the drawing. But here I have considered 50 times the diameter of the bar. My lap length and development in both are 50 times the diameter of the bar. Sometimes in the drawing they mention you have to take a lap length of 47 times the diameter of the bar. In that case, you take 47 diameter. For a few times they mention 60 into diameter of the bar. You take 60. But here I'm assuming, not assuming, usually we go with 50 into D. So I'm taking 50 into D. Okay, very simple. So how many lap length will come? See, now you may ask me one question. Sir, total height is this much. One straight bar, 12-meter bar, we never give because your rebar will fall later. So what we do, the usual practice, what we do is every floor we give one lapping. What we do? Every floor we give one lapping. Simple. So once your bar start from the foundation up to the center of the plinth beam, you give one lapping. Again, you ask me, so why it has to be given in the center only? For the very same reason, in the center, the bending moment will be minimum. If I ask you to draw the bending moment diagram of a column, if this is my column, this is my column, and when the load comes on this, how the bending moment will happen? If the load comes on this, how the bending moment will happen? So the bending moment of this will be something like this. Okay. So if this is my column, if I ask you to plot the bending moment, your bending moment will be like this. So here it will be a maximum bending. Here also the bending will be maximum. Okay, bending will be maximum, and it will be joined in this way. So this center portion, whatever you have, no. So this center portion, whatever you have, no. Here your bending moment will be minimum. So wherever the bending moment is minimum, there only we have to do lapping. Why? Because whenever you do the lapping, this becomes a weak joint. So there is every chance from here your rebar may come out. Okay, come on. So whenever we lap in such a zone where the bending moment is minimum. So that is why at the center we do. That is why you can see everywhere. No, I've taken it to the center. This is center. If this is floor to floor height, center of that I've done the lapping. If this and this is floor to floor height, center I've done the lapping. Getting my point? Okay, that's it. So what you do, you don't have to do in that way. Just remember every floor I'll do one lapping. Now from here to the top of the plinth, middle of the plinth, this is one floor, one lapping I'll do. From the plinth to the first floor, I'll do another lapping two. From here to the top, I'll do another lapping. So total how many lapping will come? Three lappings will come. Three lapping. So I just have to multiply three lapping three into what is the lapping length? It is 50 times the diameter of the bar. So 3 into 50 into diameter of the bar. If I do, I'll get the total height of that. Pretty simple. That's it. So I'll go back to this. I'll go back to this. Yeah. So what I'll do, I'll have to add that. No. Yeah. So what I'll do, come here. Yeah. So this I'll say plus. Oh, it won't be minus. It is plus because we are adding the bar here. It won't be minus. It will be plus. Plus how many times? Three times. Because from plinth to from foundation to plinth, one lapping will come. From plinth to first floor, another lapping will come. From first floor to second floor, another lapping will come. So total three lapping will come. So 3 into what I'll do? Sorry, 3 into 50 times the diameter of the bar. So 50 already it's written here. Lap length 50 multiply by diameter of the bar. Column diameter, how much it is? I've written 12 here and close the bracket. Hit the enter button. Finish. How much it's coming? 14110. Same answer I got here. That's it. This is how you are supposed to find the cutting length of the column rebar. I explained you for this. In the future lectures, we'll do all this calculation. This calculation is very simple. You're done footing. You got the total cutting length. You add this one. You add this part. You add this part. You add this part. You'll find the total cutting length of one bar. Then you have to find how many bars are there. For that, it is directly given in the drawing. It's not like footing. Directly they will mention in the drawing. Like here, if I come, it is mentioned that your C1 column. This is my C1 column, no? C1 column. It is 200 by 350 size, 16 diameter, 8 number. Finish 8 number. I found for 1. So I'll multiply this by 8. I'll get the cutting length of all the 8 bar. And then if I multiply this by the unit weight of 16 diameter bar, I'll get the total weight of the steel. Pretty simple. So up to here, try to do this calculation manually. Whatever I've explained you do it manually. Apply your logic because in a single go, you don't understand this because you have to break this into three parts. First, what you'll do, development length. In that, you will deduct, you'll find this length. Then in the total development length, you will deduct this part, you'll get this one. And then from there, you have to add all these heights. Pretty simple. So try to do up to here. In the next lecture, I'll teach you how to do all these things. So if you understand one column, no, after that, if I give any drawing, you'll be in a position to do that. But this concept you need to understand. Now, there may be few questions. Sir, there's one bend here. Why didn't you take that? See, again, for a very same reason. Few people add bend deduction. Few people don't do that. If you want to add bend deduction, come here. Bend deduction. Okay, that when it comes to a cutting length, I'll explain. Not now, no. Yeah, when it comes to the total cutting length, that bend deduction part I'll explain. Now you carry on up to here. Okay, simple. So we'll see you back in the next lecture. Thank you.